Hello, I am Hongfang Zhou, a PhD student from S-Lab at Nanyang Technological University. I'm going to introduce our work, Versatile Multimodal Portrayal for Human-Centric Perception. In this work, we aim to tackle the problem of human-centric portrayal for two reasons. Firstly, human-centric perception plays very important roles in many applications like autonomous driving, smart city, and virtual try-on. However, the cost to acquire and annotate large-scale human data is extremely high, especially for dense prediction tasks like dense pose and part segmentation. Therefore, it is important to study human-centric portrayal to achieve efficient downstream task transfer and performance boost. General portrayal methods have been explored for years. However, human data, due to its multimodal nature, should be treated more carefully to fully achieve its potential. Specifically, we classify different modalities of human data into dense and sparse representations. For dense representations of human data, we have RGB, depth map, and infrared. These representations are generally rich in texture and can provide 3D information, but they are low-level, noisy, and inevitably redundant. For sparse representations like 2D or 3D key points, they are semantically rich and structured. However, they obviously lack details. So, how to combine both types of human data modalities to fully achieve its potential in human-centric portrayal is a question we try to answer. In this work, we present HC-MoCo, the first multimodality human-centric portrayal framework that follows three design principles. Firstly, following the mutual information maximization principle, which is proved effective by many contrastive learning works, we propose to globally align embeddings of different modalities. Then, considering the downstream dense prediction tasks like dense pose, the feature space should be continuous and ordinal. Therefore, we apply soft ordinal contrastive loss terms on paired dense representations to encourage such continuous and ordinal feature distribution. To further make use of the structural information provided by sparse representations, we introduce structure-aware semantic consistency inter- and intra-samples. Combining these three design principles, we have the hierarchical contrastive learning targets. Deriving from the general paradigm of HC-MoCo, we experiment with one instantiation of it. We use RGB and depth map as dense representations, 2D key points as the sparse representation. To prove the effectiveness of the proposed HC-MoCo, we transfer our portrait model to 4 downstream tasks on different modalities: dense pose estimation, part segmentation on RGB images, part segmentation on depth map, and 3D key points estimation from depth map. With only one-time portrayal, we boost the performance of all 4 downstream tasks by large margin, especially under data-efficient settings. Aside from boosting the performance on downstream tasks, our multimodality portrayal also shows its versatility in cross-modality association and reasoning. Here we show 2 applications. For the cross-modality supervision, we want to train a segmentation model for depth input but only with RGB annotations, which is not feasible generally, but with the help of HC-MoCo, we can train a segmentation head for the RGB branch and can be directly attached to the depth branch during inference. For the missing modality inference, a shared segmentation head can be trained along with HC-MoCo contrastive learning targets, and we can inference only with RGB or depth input. Experiments on both applications show the effectiveness and versatility of HC-MoCo in cross-modality association and reasoning. Although RGB human parsing has been well studied, human parsing on depth or RGBD data has not been fully addressed due to the lack of labeled data. Therefore, we contribute the first RGBD human parsing dataset, NTU RGBD parsing 4K. Hopefully, by contributing this dataset, we could promote the development of both human perception and multimodality learning. To conclude, we are the first to formulate human-centric portrayal as a challenging multimodal contrastive learning problem, and we propose a comprehensive framework HC-MoCo for human-centric portrayal. We perform extensive experiments on downstream task transfer and cross-modality reasoning to validate the effectiveness and versatility of HC-MoCo, and we propose the first RGBD human parsing dataset. Our codes, datasets, and portrayal models are available on GitHub. Thank you.